Great. Looks like we got a pretty good quorum. Thanks everyone for attending. So we have, actually, let me move this down so we can save it and just dedicate the end period to it. Aha. Come on. Got it. All right. Let's go ahead and get started. And I think Michelle, you're probably put this first one on here.
Probably. Oh, the public
I'm
calendar.
sorry,
Yeah.
the public calendar.
Yeah, that's a new feature that they just released in LFX that just gathers. It basically does what the current Ether public Google Calendar does, but it syncs with the meetings within LFX, so I don't have to go manually update it if times or things get canceled. So
That's good.
this is the link to use moving forward, and it also includes like a button for folks to register for the meetings for each instance. So,
All right. So we should get this. I'll get a link to this in the wiki somewhere and the web page as well.
yeah, wherever the old Google Calendar link is, this should be replaced. I don't think we had moved the other or widely advertised the other one. So
Yeah, well, I think it's there somewhere, but good.
Yeah.
I don't know. Is there any other infrastructure news?
We have the staged website.
So what is it? What will it take to turn that live?
Just you guys giving the thumbs up.
Oh, okay. Well, so let me. I'm trying to think if I've got a link to it somewhere, and I don't know that I do. Oh, here it is. Oh, go ahead.
I was
Yeah.
just gonna see
So
if yeah.
yeah, the Linux Foundation has a kind of a standard web form. This is a staged version of it, but it's basically the stuff that I had slapped together, slightly reformatted and LF branded, which is fine.
Yeah, and this is in WordPress, which is approved and
Right,
ready to
that's the
go.
big advantage here. So, yeah, I'll sync up with those that need to approve, but let's go ahead and bring this on, get this as the live version.
Okay, sounds good.
And just, everyone else can see it here. It's basically the stuff that you'd seen before. I'll stick this in the chat. So if you
Yeah,
want to,
I literally just sent Craig the link to the one that you had set up and let him know, like, we just want to move all this content over basically to a WordPress site.
okay,
So that's what he did. So that's why the logo is a little funky, because for some reason we have had a hard time of making an SVG of the Ether logo and preserving um the colors and how they have like a gradation to them.
yeah,
So we can work on that, and we've been able to get successful logos for the other projects. So I don't know why this one is being so difficult, but that's just kind of what he used in the meantime.
okay, good. All right, let's see, let's come back to no, I'll just make note of that. The prototype web page migrated to WordPress. Live soon. Fingers crossed. Whatever the emoji is for that. So let's do a quick update of QA, and then we have the presentation of some results. So Kunal, before we get to your bullets, I just added one of my own, which is that DAF is now making good progress reproducing the Jenkins integration tests And I just referred to it as all the VM prep is now explicit. So he just showed me an example, but just so everyone gets a sense of it. There's a bunch of stuff that happens when you first bring up the VM that had been, the original version of it had some hidden values that just got copied in, but now, for example, figuring out what my IP address is on the machine and then go in ahead and sticking that into the host.inventory file and so on. So here's the sed script actually added in where it's needed. That kind of stuff. So he's expecting to get all of this done on all the integration tests in the next several days. Hopefully we'll have pretty good progress by next week. Kunal, you have a couple points here.
Yeah. So we are facing an intermittent issue now where UPF is getting stuck in terminating state. So I think I have raised it to Gabriel. Not sure if he's here. So
here.
yeah, yeah. So yeah, so sometimes what happens is the UPF keeps restarting and it gets stuck in the terminating state, and due to that the job gets failed. So I'm not sure. I mean, I tried looking into the logs but could not find much significant progress on that. But yeah, if someone from SD core team can help me in uh, what exact logs would be required and where exactly needs to look into, then I can provide the logs as well.
This machine where you're running is one of the machines that are running on AWS, or is some local machine you
Yes.
guys have in your lab, or is there a way for us to access that machine to have a better understanding of what's happening?
Yeah, definitely. These are AWS machines, so I can provide you access into it.
Yeah, you can
It's
share
also the
access with
case
us.
that,
Yeah,
Gabriel, it's also the case that these jobs write log files to some preserved state every time they run.
yes. Yeah, we have.
Yeah, you can share those
Logs.
logs. That would be great, at least to have a better understanding what's happening. Because I haven't, I don't see that kind of issue, at least in my local setups.
Mhm.
So Kunal, next time you see a job like that, could you just post
Yeah, actually, I kept
a link
one
to that
job.
particular job so it's very easy to
In
find the log files?
Yes, I kept one job in that state only, so I can share that one. Um, I mean, if he wants to, if anyone wants to look into it.
Good,
So
thank
should I
you.
Sure.
share? Yeah.
Where should he share it?
Yes.
I guess it could be Slack, either SD Core Dev or Aether TST. I don't know what everybody thinks. Probably SD Core Dev, I guess, would
Yeah,
be the
SD
most.
Core Dev sounds like the right place.
Mhm. Sure.
All right. So I'll just make note. Okay. I can all keep going.
Yeah. So for GitHub Actions, I just wanted to, I mean, confirm that as we are moving to GitHub Actions, are we going to, I mean, keep these jobs in Jenkins or not? Because
No, that's not, it's not on
Mhm.
the immediate. And the reason is that we still need to engage AWS. And so, and we've got all this state right now in Jenkins. All I want to do is to get that Jenkins configuration definitions into GitHub, but not use GitHub Actions. We're still using Jenkins.
Okay. So we'll still be using JJB definitions for
Yeah,
creating
that's
this.
still,
Okay.
So yeah, so I'm just making note here. The short-term goal is to use JJB depth so that job configuration is visible and editable in GitHub.
Mhm. Sure. So
Okay, and then your last bullet?
yeah, throughput test with UE ransom. So for that, I mean, with AWS, as we discussed earlier, that we were getting a very less throughput there, and um, shall we? I mean, and all the um, machines are on AWS only. So shall we still keep our throughput test on
Yeah, we
Jenkins?
still want the throughput test and we want it that other people can reproduce it. So the fact that we aren't necessarily getting the best possible throughput numbers is not the point. The point is anyone can then reproduce those number
Mhm.
configuration on their own machines under whatever conditions make sense to them.
Mhm.
And I think I'm hoping that the next presentation helps to shed light on what's possible and maybe that will suggest some changes we want to make.
Yeah.
So let me,
Definitely.
yeah, so the goal is to show best practices in how to measure throughput. Don't really care about the AWS numbers per se.
Okay.
I mean, that's a totally an artifact of the where we're testing it, and we're not trying to optimize those.
Mhm. Got it. Yeah.
Okay, good, thanks.
Thank you.
Okay, so Gabriel, are you on deck now?
Yep.
All right, I will stop. Let me stop sharing and grab the screen if you want.
Sure. Give me 1 second. Let's see where it is. Yeah. Yeah. Hi, everyone. Um, Today we're going with Suresh. We're going to present the packet testing framework. That's a kind of like a UPF capability that is meant for developers to primarily test the user plane part of the UPF. To give you why we're bringing this up is this is a capability that was working before all the way up to probably 2-3 years ago, and then at some point, and actually there was some Jenkins job running this capability, but at some point in the past, basically the machines where this was running went away, so the job stopped working. And the GitHub repository started kind of like, there was kind of like a flag of showing that, you know, the line rate tests were offline. So when digging deeper on this, it turns out that the whole packet testing framework was offline. And then what we did is we are trying to bring it back to be, you know, to use to run either line rate tests or making sure some other the UPF capabilities are working as expected. That's kind of like for more like historical background of what's happening with this. So the last probably month or two, we brought it back. It's kind of like working. We're working with this locally, and you know, other UPF users can actually test use this capability to test their own new things that they may plan to implement. In general, the packet testing framework is, you know, developer is primarily thinking for developers in mind to evaluate and assess new UPF features, right? So either creating a single packet, or basically doing line rate test in there. So the whole framework was developed in Python, and it includes two sets of tests: the unary tests, which is meant primarily to kind of like single packet tests to make sure that rules are properly inserted in the UPF, or the line rate test to kind of to achieve, you know, the maximum performance that can be achieved through the DPDK deployment of the UPF. And it has also a few individual components inside the line rate test. For this, the packet testing framework relies primarily on T-Rex for traffic generator. If you guys are not familiar with T-Rex, T-Rex is a DPDK-based traffic generator that allows, you know, to create, and also T-Rex relies on Escapi for the creation of the specific packets that need to be sent, and later on can be received. To provide a little bit background on the UPF itself, the UPF has two components. It has a PCFCP agent, and it has Berkeley extensible software switch. The base is basically the heart of the UPF in this case, that takes care of forwarding receiving packets, processing packets, and forwarding them as required. And the PFCP agent basically takes care of receiving messages from the SMF through the N4 interface, and to be able to insert those rules. So from this perspective, there is the UPF, the BES UPF, there is two ways to insert rules inside BES, either through PFCP messages or through gRPC messages. For the case of the packet testing framework, to make things easier, the interaction or the insertion of the rules is done directly to gRPC messages. That's basically allows the direct communication to insert either the PDRs, FARs, or QRs rules into the UPF. And the PTF relies on this kind of communication. So overall, the workflow of the PTF primarily requires two machines for this. In one machine is where a T-Rex is going to be running, and the other machine is for the UPF itself. And how the workflow, either for the unary test or for the line rate test, what it does is a first step. Basically, the rules are inserted on the UPF, and as I mentioned earlier, this is done through gRPC messages. Then, depending on what is the mode of configuration, either unary test or line rate test, T-Rex through Escapi basically creates the packets that are going to be sent to the UPF. And yeah, the UPF, since the rules are inserted there, is going to process the packet accordingly and then send those packets through if it receives, let's say, through the N3 interface, it's going to send them back through the N6 interface. Then from these two machines, basically to set up the PTF, we have these two machines. In one machine is exclusive to run T-Rex in there. You know, somebody who wants to do this basically just needs to install T-Rex and make it run as a demo. That's all that needs to be done in the machine where T-Rex is going to be running. Then the other machine where the UPF is going to be running, we have to deploy the UPF in DPDK mode. So in this case, the UPF runs by itself. So in a standalone mode, meaning just getting the UPF repository and deploy it as a set of Docker containers in there. That's meaning a standalone, meaning that there is no SD core or the rest of the components of the control plane or the 5GC control plane are not there. It's just the UPF itself. For people who are not familiar with how to deploy the UPF, there is inside the UPF repository, the docs install, there is a section for the configuration of the DPDK, to deploy the UPF in DPDK mode. The install mode basically they provided the details to deploy the UPF in the different modes, either AF packet mode, AF XDP mode, CNDP simulation, or we need to concentrate on the DPDK mode itself. But besides the specific instructions shown in the installation of the UPF, there is three things that need to also be taken into account. One is we need to set the measure flow to true. And the name for the interfaces, for the entry interfaces need to be updated to access, and the N6 interface need to be updated to core. This is because the unary test and the line rate test rely on having measurements to read the measurements that happen on, let's say, the amount of traffic and things like that. To be able to read that information, it needs, to collect those measurements, and to be able to collect those measurements per flow, it needs to be enabled. And also when Kana tries to check packet drops and things like that, also that relies on the name of the interface, which in this case is core interface. So this first part is just kind of deployment of the UPF in DPDK mode, given these three additional components that need to be taken into account. The second part is basically everything that has with the PTF itself. So the first here, we move into the PTF directory inside the UPF, and there is three different configuration files that we need to update before we actually make any other we start using it, right? So the first component is this .env. This file basically has the two IP addresses for the two machines that we are using. So this is actually being used to be able to control from the UPF machine to be able to launch the test from the T-Rex machine. So basically to control T-Rex on the other machine. So this is the information needed in here. Along with the configuration file, this configuration file is used to configure T-Rex. So basically, what are the MAC addresses for the source and destination parts. So this is information that is being passed to T-Rex. And also we need to update this LAN rate common PY. This is a file that we kind of created to consolidate. As I mentioned, the line rate test had three different type of tests, and each of those tests had their own MAC addresses to be updated. To make things simpler, so we created this common PY. So it's a single place where we need to update MAC addresses as well, to make things simpler for the deployment of and use of these all these different tests. So basically, these three different files that need to be properly updated. Then we need to kind of create an image for the PTF. So this image is the one that takes care of consuming all these different information to later on pass that to the T-Rex machine. We build that image for the PTF, and then we are kind of ready to run the tests themselves. The typical format is going to be run tests, basically the directory that we're interested in, either unary or line rate tests. And if you want to go deeper in a specific test, either because in the directory we have multiple tests in there. So if you want to go into details on a specific test, or whether you're interested in running all the unary tests or all line rate tests. So first bullet is an example to run all unary tests. So basically by doing this, you are going to run all tests that are in unary. And if you want to be more specific, the second line shows an example of to be more specific, right? Whether you are interested in running a specific downlink performance baseline test, so you can use something like this. Okay. So this is just kind of a background of what the PTF is, how, it was working before, it's still working now, we brought it back, and now Suresh is gonna run a demo on that part. Suresh, would you like me to show this figure here for you to explain?
Yeah, and let me share it, and probably will go take over that. Gabriel.
Okay, sure, take it out, go ahead.
Let me know when you guys see my screen.
Yeah, we can see.
Okay. Okay. Out. Okay. So before running the actual test, I would like to just show how does our setup is connected, and so that when I show the configuration changes, it will be easily relatable to see, okay, where we are configuring, what MAC address it is. So basically, as Gabriel mentioned, we need two servers. So where we are running the UPF on one machine and the T-Rex on the other machine. So our we have used two NIC ports connected back to back. So in order to achieve a clear without any switches, just to make sure no other packets received, because the T-Rex and the packet testing framework is relying on the packet counts it sends and receives to be precise to identify whether the test is successful or not. So it is important to connect it back to back to avoid any noises in the network. So we have connected two NICs, which is connected on the socket 0. And this is our MAC address for each of the NICs. And probably we will show in detail where we are going to use this. Basically, the N3 and N6 MAC addresses on the UPF side and similarly on the T-Rex side. And this is a IP address for the T-Rex machine and the UPF machine. So which is we are going to configure it later. So one thing to note here is the flexibility we have is we can either run this test from UPF machine or T-Rex machine. So we just need to configure the IP address. Where does this process running? Then the PTF will take care of automatically pushing the appropriate configuration files and running the appropriate test. So before running the test, I will go to the README so that you can easily relate, okay, how you can set up this, and I will show step by step configuration and the test. So as I mentioned earlier, the PTF expects the UPF is already installed in the DPDK mode in the standalone mode. And we have already installed the T-Rex. So in case if you want, if you are first and how you want to deploy on the procedure and other stuff, you can always go here and refer and just deploy as it is. And the T-Rex installation guide also linked here. You can just use this for the time purpose, because it will take time for freshly install the T-Rex and UPF. So we have already configured, and just for the purpose, I'm going to show you how did we install here. Basically, ah, so on the right side is my UPF machine. On the left side is my T-Rex, where I'm running the T-Rex daemon. So if you can see here, we have installed all the base and PFCP route control and all other components, which is part of the UPF. So which each runs in the Docker container. One quick thing I would like to show here is the configuration Gabriel is talking about. And mainly we need to take care of the access and core interfaces. So the access core interfaces, another important thing is the measure flow should be enabled, because the framework is relying on certain counters, which is enabled by enabling this parameter. Otherwise, some of the tests might be failing.
Sorry, just one thing.
Yeah.
The access and core also has to be on the Docker setup script.
Yeah, right. And I'll show that one. So on the left side, you can see the PTF directory structure. I'll just quickly go over what lies where and how we can use. So the config directory, you can see, contains all the configuration files needed to run the PTF. So what we did here is the Docker setup and the UPF JSON. These files exactly used to deploy the UPF. So we just keep these two files in this place. The reason is the user can just refer with a specific setup, set of MAC addresses, what are the changes need. So this three files contains a unique set address, which easily can work already a working setup, so that they can easily just refer and update accordingly. And this list folder Basically, this contains all the APIs and other utility functions which is needed by the PTF. For example, interacting with the BES to install the rules and get the stats and other stuffs and the other utility functions which is used here. Then the test folder. So this contains the actual test we wrote for testing the UPF. So as of today, we have two set of tests. One is unary and the line rate test. We will go through each of them, what its significance and what is the difference in the each test basically. So if you can see. The unary test, as already mentioned, it is not a performance test, basically to check the functionality, the rules, basically just installation of the rules and deletion, whether the communication between the base and other stuff works fine or not. On the unary, on the line rate test, we have an extensive test. As of today, we have a three lines of test. Basically, the baseline test, which basically just test the performance. We can configure the number of UEs and what is the data rate and the packet size, what we want to test. All these things we can configure. I will show you how we can configure that. So basically, this will just send the packets in the downlink, and the PTF will, the T-Rex will send pump the packets, and this will measure, okay, whether in case of any packet drops and just to flag it based on the stats. And we have the maximum bitrate MBR pi, which is almost similar to the performance test. But what this guy will do is, which includes some kind of negative test. So for example, if I configure the bit rates, for example, as 1,000, so this guy will send with a different throughput, the packet rates like 10 Mbps, 20 Mbps, 50 Mbps, 200 Mbps. He will try different packet rates, and he will send, for example, 1,000. If I configure, he will send less than 1,000, which is basically in this scenario, he will not, he's not expecting any packet drop. And in the non-conforming test, there is a negative test. He will try to pump more packets than the configured bit rates. Then he is expecting, for example, 1,000, if he configured, he will pump 2,000 packets and expects 50% of the packet drops. So kind of a negativity test. And the third range is the QoS metrics test. This is almost the same as the baseline, the performance test, except that what this guy will do is, he will collect the latency, jitter, and other informations per session, and he will measure and display accordingly. So these are the three set of tests we have today, and we can always enhance based on our need. Probably we can add if it really any kind of any specific modules or features needs to be covered here. So I will quickly go through the configuration here. So what we are doing here is only these three files we have to update. So I will quickly show. So in the env file under the PTF directory, we just need to configure what is the UPF and the T-Rex IP. So here we just configure them. And the second one is the T-Rex. So here we just need to configure according to our setup, what is the PCA, the NIC addresses we were using, and what is the MAC address in the back-to-back connection. If you see in here, so I just configured this guy. So based on this MAC address details, I configured here the source destination MAC for the uplink and downlink. So these parameters and all you no need to touch. Already we have configured and identified the optimal value for the mBufs. So probably you might need to update the platform here. So especially based on where your NIC is connected on which socket, accordingly you might need to update the socket ID and the corresponding thread IDs so that you can get the optimal performance with the T-Rex. Then the last one is text related parameters. So here only we will be configuring the MAC address for the T-Rex source MAC address, where in the downlink what I'm going to pump. Then N3 MAC address for UPF, then N6 MAC address. And these ports we no need to change, because since already it is fixed, we are going to send from downlink, and we will be expecting the packets on a specific ports. Probably we can play with this guy. So the test related the duration and what rate we would like to pump the traffic. Probably based on your NIC, the connection bandwidth, probably you can try various rates and number of UEs. So by default, we configured 10,000 UEs and the packet size used. So basically for the baseline test, the packet size used is 64, and for the MBR test, the packet size configured is 1400. And similarly, we have configured the UEIPs. Most of the scenarios, you no need to touch all these parameters. So because the corresponding parameters are already taken care in the UPF, the Docker setup. So we will not no need to change here. Mostly you will need to update only the MAC address. And if you want to play with the rate and other thing, you can play here. These are the just three places you have to change. Then, as mentioned here, you just need to run the make build. So which already I have built. So I'm not going to run it again. Let's try to run some tests here to see how does it happen. So I'm running the unary test here. Let me bring up. So basically what this guy will do is it will check whether the PTF and the daemon and everything is running or not, and he will remotely push the T-Rex configuration and run some of the tests whatever we have configured here, and the test results will be stored for each test under the directory with a separate XML file. So since it is a functional test, it just closed very quickly, just checking the rules, whether it is deleted and other stuffs. We can see the status here, whether it is successful or not. I'm going to run a performance test now, and I will show you how does the rules and other stuffs updated in the pipeline as well. So if you can see here, basically this guy is interacting with the server and he is pushing the information. Now he is installing the rules for 10,000 UEs we configured. I'm going to show you in the pipeline. How does it reflect here? So you can see here the rules in the PDR lookup and app QER lookup is increasing. Basically, for 10,000 rules, we need to install first the rules. Then he will start the traffic. And here it goes around 4,000. We'll go back here. So here basically the logs and other stuff will be stored in the logs directory where we can see in case of anything goes wrong, probably you can just always go and check it in the logs directory to see in case whether he is able to communicate with the T-Rex and other stuff. So one thing I would like to note here is we were using the T-Rex version 2.97. So we were trying to use earlier, I think sometime back, the default, they were used a very older version of the T-Rex, but because of the version discrepancies with the gRPC and other some libraries, we were not able to use that anymore. So in case if you are using, probably keep in mind, at least you have to use version 2.97 in order to keep the gRPC and other packages in line. And that is one thing probably we need to capture in the documentation. I just forgot that we haven't mentioned the specific version for the T-Rex. Let's see whether the rules are done. Okay, almost we are close to 38,000. Okay, so now the rules are installed. We can see the packets flowing through here. So we were expecting, we configured as I shown there, 100 kbps we configured for 10,000 UEs. So we should see 100 kbps packets flow here. Let us wait. Because what happened is in some of the scenarios after installing the rules before starting the traffic, we had some kind of issues. Okay, I will talk about that later. You can see the packets flowing now here. It's not refreshing. So this game, okay. For that, I think the West pipeline is just stuck. Let me reload it. Okay. Since we ran it for 10 seconds, probably the packets already passed. We will see in the results. And you can see it here. Okay, once the traffic run, it will gradually just close the connections, whatever the installed rules. You can see the PDR lookup 0 rules. It is already removed that. And the QER lookup, you can see it is gradually dropping. So once all the rules are, basically it will just install and clean up so that it can just clearly let down the system in clean state for the other tester to come and run again. So here you can see, okay. So all test were rules, everything is removed. Let's go back and we can see here. So basically, you can see the test is ran okay. And basically, it is not showing the number of packets and other stuff here. In case of any issues, for example, the sent packets and received packets, in case of any discrepancies, basically, if the test were fails, then it will give you the detailed description here. So on, okay, how many packets sent, how many packets lost and other stuffs and all. Since here, there is no drop and everything is fine, we can see the test is successful and the data is stored in the baseline test. YAML file. And I think, yeah, that's it. And probably quickly I can run the MBR test as well. So which I can, which is basically the negative test, basically pumping the packets more than the configuration and see whether the packet drop is as expected or not. So as I mentioned here in the downlink, you can see it will test with the different packet rates. So now he's running the conforming test. Basically, he's pumping the packet less than the configured bit rates. So there is no packet loss expected. So less than 0 packet percentage packet loss is expected for this particular test. So this test is successful. Now this guy is running the non-conforming test. So basically what he's doing is he's pumping the packets more than the configured rate. So he's expecting at least 50% packet drop, because 1000 is the maximum bitrate configured. He's pumping at 2000 packets. So you can see here the 50% packet drops, which is expected, and the tests were successful. Similarly, we were running on the downlink. Similarly, he will run on the uplink as well. That's the MBR test. And similarly, the QoS metrics, as I mentioned, he will run exactly the performance test, baseline performance test. Only the exceptional thing is he will just get the latency and jitter per session, and he will check the latency and other stuffs, and based on that, he will declare whether the test is successful or not. So these are the broadly 3 categories we covered. And yeah, with that, I'm done. Probably we are ready to take any questions or any queries.
Are you sending these packets per session or every session?
Yeah, every session. Yeah, we installed 10,000 UEs per session. It will be the packets will be distributed.
It's distributed. Like you're not sending like 20 Mbps per session, right? You're sending
no, not like that. It is just a distributed.
Okay.
And we can run, and not only we have the flexibility to run a specific test. If you want to run only a specific feature or something like that, you can always run with the capability and just only the specific set of test. And yeah, so which is very helpful just to verify any performance and other kind of things. So the only thing is you don't need other components, the core components, where we were just everything is we were installing the rules through the gRPC. So you don't need any other core components. You can just verify your UPF in case if you are just developing any new feature or anything, and just you need 2 servers. That's it.
Since you're using Scapy only to install the rules, right, for PDR and FAR, so you can also use, I mean, that to install directly through the PFCP also, right?
Yeah,
Yes.
we can.
Yeah.
Yeah, we can. Yeah. We can use the PFCP, but here the thing is, since we have, we just want to avoid the other components, and we can directly, since you have the access there, we can just, our intention here is just to verify the rules and the traffic, the packet drops mainly. So whether it impacts anything, yeah.
So the packet testing framework overall is concentrated on the user plane of the UPF itself.
Yeah.
Looks great.
Yeah.
Other questions? I just wanted to, thanks for the presentation. I just wanted to make sure we get this recorded properly. I put a link to what I believe is the documentation, which is the README file in the repo. And Gabriel, if we could get a link to the deck, if that's possible, that would be great. Just add it to the minutes here.
Sure.
I left a hole for it.
So just following the README, you should be able to, without any hindrances, you should be able to reflect and run this test. Just in case if you are getting into issues, just let us know. We have documented as much as possible without any steps in this. So, and we try to automate most of the steps required, and just to reduce the places where we are configuring the parameters. So mostly only the 3 places we will mostly need to update. So let us know in case of any issues, we can update and always just enhance it.
So definitely this is something that I would like to try, and I'm very glad to hear that you're available over Slack in case I have any questions. This is something that I would like to try this week.
Sure. Yeah.
Thank you.
Sure.
Can we run this on Cloud Lab or something? Or it needs can we run it on like Cloud Lab kind of VMs?
And you should be, but we have tried so far in bare metal systems probably. And Gabriel, have you tried it on any VMs so far?
I think it's doable. However, the key piece here is not just the unary component, that would be kind of like transparent, right, to the type of deployment of the UPF. But the important piece in here is the line rate tests themselves to kind of see whether we are not affecting the performance that we can achieve in a native DPDK deployment. As from that perspective, we are trying to kind of have these bare metal machines in DPDK. I mean, that's more from that perspective. So it's gonna be doable, right? But from here, what we are trying to do is concentrate on the line rate such that if somebody makes a change, such that the line rate doesn't get actually affected, the performance of the UPF doesn't get affected, or if it gets affected, why it gets affected. So the idea is to understand, make sure that nothing decreases the performance of the UPF, and that's why we're trying to see how how to continually evaluate that we can get the maximum performance always, regardless of the changes that may be done, or regardless of the additional features that can be added to the UPF.
On that note, Gabriel, have you thought about how to turn this into a regression test, or is that a little too much at this point?
Well, there are a few things in there, so it could be done, but so as you can see, as you saw in Suresh, so we have already one set up that at the moment we are deploying it manually. Our next step is to kind of like automate that test to do some, let's say, nightly tests. But that would be some internal stuff that we are doing in here.
Yeah.
As Aether or Linux, is there any infrastructure that we can actually, use to have this for the regression tests?
Does the Linux Foundation offers anything here, Larry?
Right.
I didn't quite follow that last little exchange.
I mean, does the
Christian,
Linux
what was your
Foundation?
question?
Yeah, does the Linux Foundation offer some machine or some ways to do it?
Yeah, no,
Infrastructure.
not that I know of.
I see.
Okay. Yeah. It's a really good point. I've got a stash of physical servers that I use. You've got a stash of physical servers, but there's nothing that's project owned, so to speak. Well, this is great. At some point, we probably ought to do an audit of the various tests like this we have. I mean, and just another example that comes to mind, we've got the API tests, but those kind of run in a framework and it's not regularly run. But as long as we keep testing them manually, we're okay. Am I missing any? Does anyone else know of any tests on that are like that? And I'm not counting GNB Sim because we do run that regularly.
And GNBC, you run it in the ONF environment, or?
Yeah, it's running all the integration tests. That is our default test. All right, well, to be continued, but thanks for the report. Are there any other questions or any other topics we need to get to?
I actually forgot to ask, what's the MTU that you're using for these tests? Are you using jumbo frames?
There's two packet sizes depending on the type of testing. One is the 64 bytes that Suresh showed, and the other one is, I think it's 1400 or 1000. 1400. Yeah, 1400 bytes.
Oh, okay. So when we're talking line rate, like at 10 megabits, that's not necessarily achievable without jumbo frames. What does that look like? Oh, well, I'll see it. I'm sure once it starts getting going, I'll be able to sniff it and see what exactly is going on. So.
Mm-hmm.
That was it for me. Thank you.
Okay, good. Thank you. Anything else? All right. Thanks, everybody. See you.
Just one update, Larry, regarding the rock Helm charts. Since Sean is here, we moved the Helm charts the rock Helm charts from Gerrit to the Honest Project organization. Now they are there. DAF is going to help us setting up the secrets such that new updates to the Helm charts can be directly published to the Aether project charts. GitHub actions are in place, but for now is a draft. The pull request is a draft because again we are waiting for DAF to help us with the secrets. Yeah, so that's something that is already there in GitHub now.
Sean, are you involved, or are you just watching this happen from a distance?
Yeah, Gabrielle is doing most of the work, but yeah, I'm reviewing, and I managed to create that the new repo, and Gabrielle really is doing the heavy lifting.
Oh,
yeah,
wonderful.
Well, we have been working together with Sean.
Good, thank you. All right, excellent. Thanks, everybody. Again next week. Bye-bye.
Thank you. Excellent presentation.
Thank you.
Yeah, thanks.
Thank you.
Thanks, Sam.
Thank you.